Today's episode is called Did the Agent Stay on the Path? It's a question here, of course. So it's about token-based replay and alignments. And here, because I already have a video that talks precisely about alignment and token-based replay, I will try to hover over it so you can watch that other video to understand how token-based replays and token-based replay works and how conformance is working. But I'm just gonna talk about the case of having agents. That's what the video is about. So here we have a run that just finished. We have replay fitness score of 80, which is pretty good for an agent, of course. It looks healthy, but if we look closer, it skipped the confirmation checkpoint. And that's the control that really matters in our process. And it repeated web search, which is a log move here. So these are two different deviations. One is more critical than the other. Problem is that with our score, we cannot tell which one is more than the other. So nevertheless, I will give you a reminder of my previous video. So alignments make deviations concrete. You have two rows. You have this one that represents log, and then you have this one that represents the model. So the idea is very easy and very basic. You need to line them up column by column. When they both agree, that is synchronicity. If the agent did something the model never called for, that is the log move. Here we have the extra search. And then we have the gap that you see here in the model. When the agent skipped a step, the model required, as you can see here. So you have the agent skipping here, and you have a step that is present with the model. That is what we call a model move. The whole idea of alignment is that you have the two-row structure, and the optimal alignment is the cheapest way to line up the run against a valid model run. So to remember the problem from our intro, here we have allocations of costs. We have the search that costs 1 and the confirm that costs 1. Now, if you look for your alignment and you try to see the cost of deviations that you have, you're gonna put it at 2, which will make your model actually give you 2 out of 10, for example, which is not bad. Like 80% is not bad. But that's the problem. That's the flow that we discussed already. Here, this and this are getting the same cost. So there is the problem of cost allocation here. That is core to our situation. Also, I wanted to talk to you about another problem here, is that the agent searched twice. There were 2 searches, and it was one of the problems we already encountered. The model expects 1 search. Which of the 2 is the extra one? This is the question we need to answer. So reading A says that it's the second one. Reading B says actually it's the first one that is extra. So the exact location of a deviation can shift between runs. It's really hard to pinpoint which one is the superfluous one. So you can trust the counts, you can trust here that you actually need 1, but you cannot trust, okay, which one is extra. That is another problem we need to think about here. So here you can see the problem. Here we need to fix the ruler, because we said that this problem and this problem have the same weight, which is not true in real life. So, and because if we act as if they have the same weight, we get 080 fitness, which is a high score for a bad process, because we're missing a very important step. So what we will do is that we will change the weights. In this very simple example, we are skipping our control failure. So we make that model move cost 50, for example. We will just increase it by a lot. The extra search stays at 1. So this one will still have a cost of 1, and this one will have 50. Now, if I calculate the new fitness score, it will be at 0.14 now, which is now it's failing loudly. It's telling me, hey, at 0.14, your agent is really not behaving the way you want it. Unfortunately, in PM4Pi today, you cannot do this from one line change. What you need to do is you need to drop to the algorithm level API. You need to pass three things. You need to pass the model cost dictionary. You need to pass a trace cost list and a sync cost dictionary. After that, you can change the weights. One caveat, I really want to emphasize this. So I am personally a young researcher in the field, and this idea of weighted cost functions are so the weighted cost functions are established in process mining. You have papers from 2023 from Gröger and colleagues and Sia and colleagues from 2011. And they are framing them as the now for the framing as being central to agent governance. This is part of the series synthesis. So this is more something that I'm adding in 2026, and even the research is very new on the subject for 2026. So what I'm saying is everyone is trying to sort of bring their ideas forth, and this is why I'm making YouTube videos, but do not take my ideas for gospel. I might make mistakes too, so be careful around what I'm gonna say in this series, especially from this video and ahead. Now, I wanted to mention one thing is that, so I have two different videos, one that explains token-based replay and one that explains alignments. Alignments are more exact but expensive, and solving them is a shortest path search on the product of the trace and the model. And what happens is that it explodes because especially of concurrency and length. So that's a p-space complete problem with workflow nets. I will have video that explains what are workflow nets, and NP complete problem with process trees. I will have another video that explains that. This is coming from this paper from 2026. Now, for token-based replay here is the fastest alternative. It's the near linear practice. You're firing the trace through the net and you're counting tokens. You have the produced, the consumed, the missing remaining tokens. Please check my video about token-based replay if you want to see how it works more in detail. So fitness is calculated by this, also present in my video. Now, the issue is that it has a trap. This is what you call token flooding. Token flooding is when you have a run that is diverging hard. The replay is inserting missing tokens to force it. So you have every time you're adding 1, 2, 3 to go and spread your tokens. And those tokens are piling up in a place, and they enable transitions that should be blocked. In this case, in this small example, this is the transition that should be blocked. So the most broken runs can come back with a misleading high fitness with token-based replay. And these are the ones that you really need to catch. Here we are at the trade-off situation. Alignment costs more in resources. Token-based replays is faster and costs less, but it's allowing more problems. So there is a paper that talks precisely about that. It's about how the most broken runs can score misleadingly high, and I believe the name of it is the ones you need to catch. And the fix that was proposed is freezing superfluous tokens when it matters. This is something we can discuss maybe in another video. Frankly, I haven't read the paper yet, but we can explore that in another video. Generally, when it really matters, you need to prefer alignment. When you have the resources, when you are truly trying to solve a problem, use alignment. So here we have two examples of pseudocode from PM4Pi. Here you have alignment, here you have token-based replay. And here, if you look at it, you can actually see that we are doing the mitigation trick that we discussed already in the previous paper. One thing to remember is that when alignments are too slow, you have 3 escape hatches, which are decomposed alignments, approximate alignments, and the Dijkstra-less memory variant. I will not get into detail about these for now, but I might do another video about them in the future. So now to recap, you have alignment is basically the cheapest lineup of what the agent did against what it should have done. So you have your synchronous, log, and model moves. The default cost function treats every deviation as equal. So that's a problem we already have discussed, especially here, and how you need to change that. And changing the weighting is a real governance act, because you're gonna change the behavior of your agent by doing that. Also, token-based replay is also a good, fast change to alignment in case you have less resources, and even if it gives you worse runs generally. Yeah, one line to remember, a fitness number is only as honest as the cost function behind it. This is a concept that you need to put in mind. Next, for the next video, from a score you compute after the fact to checks that run while the agents runs. So that will be episode number 13. So see you tomorrow, and hope you liked my content. Please like and subscribe, and follow me on LinkedIn. Thank you.